All right, let's jump forward to work result. So work result, blackboard L. This is sort of the output of a work item. It's not quite an output of a work item, because an output of a work item assumes the work item is going to be successful in its output. A work result might include an error condition as well. O is the actual output, and it's basically either just regular data, in which case it was successful, or J, which is an error, which I think is defined somewhere here. There we are. And the error can be out of gas, panic, and then code being too bad, code being bad, I think, or maybe bad lookup after check, and code being too big. Let's go back to our work result. All right, so in the work result, we have the service, which is in our service index. It's whichever service this is, this work item was done on. We have the code of the service at the time of being reported. We have two more items, which I'm going to check. The hash of the payload, and the output, and the gas prioritization ratio. Okay, yeah. So this is one of the sort of interesting parts. So this Z should actually be an N, because it's never negative. And it's sort of how much gas the work item took when it was in the refine stage. So you're familiar with JAM services having this refine stage, which happens in core, accumulate stage, which happens on chain. Well, we have to somehow distribute the on-chain accumulate gas amongst all of the services that are being accumulated. To do so, what we do is we basically say all of the work packages have these work results. And the work results state the gas, the sort of ratio of gas that they use. Now, in normal usage, I would expect this to just be the gas that the refine stage used. In principle, it doesn't have to be, but I would think it generally would be. It would be a good default in any case. And then what we do is we use this as a ratio, sort of pro rata, distributed to the accumulate stages. So if you take more gas when you're refining, you get more gas when you're accumulating. If you don't take so much gas when you're refining, you don't get so much gas when you're accumulating. Smaller jobs for refine are assumed to have less need for gas when they're accumulated. That said, it's still very much the work package builder, so the author of this work package, that gets to decide how these things should be spread. This gas isn't how much gas the work item used, it's how much gas pro rata, as a ratio, the work item gets to accumulate with. The L, the hash of the payload within the work item, is more something that we, yes, so here we are, but it's something provided to the accumulation logic of the service. Essentially, this is just a way of telling the service, look, this is the result, but maybe the service wants to know what the question was, what the query of the result was. And so what we do is we hand it this hash of the thing that was given to the service, the data that was given to the service to the refine, right, stage. So it's sort of an identifier, essentially. We don't really care about it. We don't do anything with it. It just gets passed into the accumulate stage. We do care about the code of the service at the time that it was reported. Why? Well, we want to make sure that when the work report is is being constructed, the code didn't change before it got accumulated, right? We want to make sure that the refine code and the accumulate code are the same code. If you update a service, you wouldn't want it. If there happens to be another work package that's going on with the service that's kind of like came in before it was being before the code upgrade, but sort of got to accumulate stage after the code upgrade, it will be a problem. So we keep this hash around from the refine stage so that we can make sure it's the same when we get to the accumulate. Good. All right. So we've talked about the output. Yeah, let's just check what this bad means. So the first two are values concerning execution, all right, yeah, out of gas or unexpected program termination, panic, basically. Of the remaining two, first indicates the service's code was not available for lookup. Okay, so yeah, bad means code wasn't available when we needed to look it up. Basically, that code hash, this guy down here, C. If we can't find the reverse hash of that, if we can't find the pre-image, then we basically say it's bad. Big just means the code was too big.